Hi, in this video, I will share the ignou MCA of the subject MCS219 Object-Oriented Analysis and Design. All assignment questions were solved of June 2023 and January 2024. The first question is, what is OOAD? Explain the basic principles of object orientation. Object-Oriented Analysis and Design, OOAD, is a methodology used in software engineering to analyze, design, and develop software systems based on the concept of objects. Objects are key to understanding OOAD, as they represent real-world entities in a software system and encapsulate both data and behavior. This approach to software development emphasizes modularity, reusability, and extensibility, making it easier to manage complex systems. Basic principles of object orientation. Abstraction. Abstraction is the process of simplifying complex real-world entities into their essential characteristics. In OOAD, abstraction allows us to focus on the relevant attributes and behavior of an object while ignoring unnecessary details. For example, when designing a car object, we might focus on its attributes such as color, model, and speed, and its behaviors such as accelerating and braking, while ignoring details like the composition of the engine. Encapsulation. Encapsulation is the bundling of data, attributes, and methods, behaviors, that operate on the data into a single unit, called an object. Encapsulation helps in data hiding, which means that the internal state of an object is hidden from the outside world and can only be accessed through the object's methods. This ensures that the object's state remains consistent and cannot be modified in unexpected ways. Inheritance. Inheritance is a mechanism that allows one class to inherit attributes and methods from another class. The class that inherits is called a subclass or derived class, and the class that is inherited from is called a superclass or base class. For example, when designing a car object, we might focus on its attributes such as color, model, and speed, and its behaviors such as accelerating and braking, while ignoring details like the composition of the engine. Encapsulation. Encapsulation is the bundling of data, attributes, and methods, behaviors, that operate on the data into a single unit, called an object. Encapsulation helps in data hiding, which means that the internal state of an object is hidden from the outside world and can only be accessed through the object's methods. This ensures that the object's state remains consistent and cannot be modified in unexpected ways. Inheritance. Inheritance is a mechanism that allows one class to inherit attributes and methods from another class. The class that inherits is called a subclass or derived class, and the class that is inherited from is called a superclass or base class. Polymorphism. Polymorphism means many forms and refers to the ability of objects to respond to the same message, method call, in different ways. In OOAD, polymorphism allows objects of different classes to be treated as objects of a common superclass. This enables flexibility and extensibility in the design, as new classes can be added without modifying existing code. Object-Oriented Analysis and Design, OOAD. OOAD is a systematic approach to analyzing, designing, and developing software systems using object-oriented concepts. The process typically involves the following steps. System design. Once the requirements are understood, the system is designed using object-oriented principles. This involves defining the structure of the system in terms of classes, objects, and their interactions. UML, Unified Modeling Language, diagrams, such as class diagrams and sequence diagrams, are often used to represent the design. Object modeling. Object modeling is the process of identifying the objects, their attributes, and their relationships based on the requirements. This step helps in defining the classes and their associations in the system. Behavioral modeling. Behavioral modeling focuses on the dynamic aspects of the system, such as the interactions between objects. This step involves defining the methods and messages that objects can send and receive. Architectural design. Architectural design involves defining the overall structure of the system, including the subsystems, modules, and their interactions. This step helps in ensuring that the system is scalable, maintainable, and meets the requirements. Design patterns. Design patterns are reusable solutions to common design problems in software development. They provide a way to standardize and improve the design process by capturing best practices and proven solutions. Implementation. Once the design is finalized, the system is implemented using a programming language. Object-oriented programming languages, such as Java, C++, and Python, are commonly used for implementation. Testing and deployment. After implementation, the system is tested to ensure that it meets the requirements and functions as expected. Once testing is complete, the system is deployed to the production environment. In conclusion, OOAD is a powerful methodology for designing and developing software systems that are modular, reusable, and extensible. By following the basic principles of object orientation and using a systematic approach, developers can create software that is easier to maintain, scale, and evolve over time. The next question is to draw a class diagram for an online shopping system. Make necessary assumptions. Here's a simplified class diagram for an online shopping system. This diagram represents some of the key classes and their relationships. Note that this is a basic representation, and in a real-world scenario, the system would be more complex with additional classes, attributes, and method. The screenshot is as follows. In this state diagram, the flight booking starts in the available flights state, where users can search for and select flights. From the available flight state, users can transition to the booking state by selecting a flight. In the booking state, users can either confirm the booking, moving it to the confirmed booking state, or cancel the booking, returning to the available flight state. Please note that this diagram is a simplified representation. In a real-world scenario, the system would have more states and transitions, such as handling payment, managing user accounts, and handling errors. Explain object model and dynamic model in detail with the help of suitable diagrams. Object model. The object model represents the static structure of a system using object-oriented concepts. It focuses on the static aspects of the system, such as classes, objects, attributes, relationships, and methods. The object model is typically represented using class diagrams in UML, Unified Modeling Language. Class diagram. A class diagram is a type of UML diagram that represents the structure of a system by showing the classes, their attributes, methods, and relationships. Here's an example of a simple class diagram for a library management system. The class diagram is as follows. In this example, we have two classes, library and book. The library class has attributes such as name, address, and a list of books. It also has methods to add and remove books. The book class has attributes like ID, title, and author. Dynamic model. The dynamic model represents the dynamic behavior of a system, showing how objects interact with each other and how the system behaves over time. It focuses on the runtime behavior of the system, including the sequence of method calls and state changes. The dynamic model is typically represented using sequence diagrams and state diagrams in UML. Sequence diagram. A sequence diagram shows the interactions between objects in a system over time. It illustrates the sequence of messages exchanged between objects to achieve a particular functionality. Here's an example of a sequence diagram for the process of checking out a book from a library. In this sequence diagram, the user object selects a book and checks it out from the library object. The library object then adds the book to the user's account. The arrows represent the flow of messages between objects. State diagram. A state diagram shows the different states that an object can be in and how it transitions between these states in response to events. Here's an example of a state diagram for a book in a library. In this state diagram, a book object can be in one of two states, available or borrowed. The object transitions between these states based on events such as checking out or checking in the book. In summary, the object model represents the static structure of a system using class diagrams, while the dynamic model represents the dynamic behavior of the system using sequence diagrams and state diagrams. Together, these models provide a comprehensive view of a software system, capturing both its structure and behavior. Next question is draw a state diagram for online flight ticket booking. Also, list the assumptions made. Here's a simplified state diagram for an online flight ticket booking system. This diagram represents some of the key states and transitions in the booking process. Assumptions made for this diagram include: users can search for flights, select a flight, and proceed to booking. Booking can be confirmed or cancelled. The diagram representation as follows. In this state diagram, the flight booking starts in the available flights state, where users can search for and select flights. From the available flight state, users can transition to the booking state by selecting a flight. In the booking state, users can either confirm the booking, move it to the confirmed booking state, or cancel the booking, returning to the available flight state. Please note that this diagram is a simplified representation. In a real-world scenario, the system would have more states and transitions, such as handling payment, managing user accounts, and handling errors. The next question is, what is concurrency? Explain how concurrency is handled with the help of a suitable example. Concurrency refers to the ability of a system to execute multiple tasks or processes simultaneously. In computing, concurrency allows different parts of a program to be executed independently and concurrently, improving performance and responsiveness. Concurrency is typically handled using threads in programming. A thread is a lightweight process that can run concurrently with other threads within the same process. Threads share the same memory space, allowing them to communicate and synchronize their actions. The code is as follows. In this example, we create two threads, thread 1 and thread 2, and start them concurrently. Each thread executes an instance of the task class, which implements the runnable interface. The run method of the task class simulates some work by printing a message every second for 5 seconds. When you run this example, you'll see that the messages from both threads are interleaved, demonstrating concurrent execution. This allows both tasks to run concurrently and independently of each other. The next question is, what is the need for inheritance adjustment in system design? Explain how inheritance adjustment can be performed with the help of an example. Inheritance adjustment is a concept in object-oriented design where the inheritance hierarchy of classes is modified to better fit the requirements of a system. This adjustment is necessary when the existing inheritance hierarchy does not accurately model the relationships between classes or when new requirements necessitate changes to the hierarchy. Need for inheritance adjustment. Changing requirements. As requirements evolve, the existing inheritance hierarchy may no longer be suitable. New classes may need to be added, existing classes may need to be modified, or the relationships between classes may need to be restructured. Improving code reusability. Inheritance adjustment can help improve code reusability by creating a more cohesive and understandable class hierarchy. It can also reduce code duplication and improve maintainability. Enhancing flexibility. A well-designed inheritance hierarchy allows for greater flexibility in the system. It can accommodate future changes more easily and support new features without requiring major modifications to existing code. Performing inheritance adjustment. Inheritance adjustment can be performed in several ways, depending on the specific requirements of the system. Some common approaches include adding new classes. If new classes are needed to better represent the domain model, they can be added to the inheritance hierarchy. These classes can inherit from existing classes or introduce new abstract classes to represent common behavior. Refactoring existing classes. Existing classes can be refactored to better fit the requirements of the system. This may involve splitting existing classes into smaller, more focused classes or merging classes that have similar functionality. Introducing interfaces. Interfaces can be used to define common behavior that can be implemented by multiple classes. This can help decouple classes from their implementation details and improve flexibility. The program code is as follows. In this example, the introduction of the two-wheeler class allows us to better represent the new requirements for motorcycles and bicycles while maintaining a cohesive and flexible inheritance hierarchy.